Hello everyone, and welcome to week 3 of our Introduction to Petroleum Engineering course. This week, we will discuss geophysical methods, which are one of the most important tools used to understand what lies beneath the Earth's surface without directly seeing it. In petroleum engineering, geophysics helps us reduce uncertainty before drilling, improve reservoir understanding, and increasingly support carbon storage projects as well. Before we begin, let me briefly remind you where we are in the course. We have already covered the fundamentals in petroleum geology, and now we are moving into exploration 2, geophysical methods. This topic is very important because geophysics connects geology, physics, and engineering, and helps us image the subsurface before making expensive decisions such as drilling a well. For today's lecture, we will move through 5 parts. First, we will introduce the basic concept of geophysics. Second, we will review the main types of geophysical data. Third, we will discuss exploration geophysics, especially seismic principles. Fourth, we will examine the role of geophysics in CCS. Finally, we will close with a recap, next week's topic, and the key points you should remember. Let us begin with the most basic question: what is geophysics? Geophysics is the application of physics to study the Earth, oceans, atmosphere, and near-Earth space. It is a broad field connected to physics, geology, petroleum engineering, environmental science, oceanography, and even earthquake studies. In petroleum engineering, geophysical data are used to make predictions about the presence, nature, and size of subsurface hydrocarbon accumulations. This is why geophysics is such a critical exploration tool. This is a fun slide, but it also tells us something real about the profession. People often imagine geophysicists doing dramatic earth science, complex physics, or abstract mathematics. In reality, geophysics combines all of these. It is both scientific and practical. In petroleum engineering, geophysicists often spend their time analyzing seismic data, building subsurface interpretations, and helping reduce uncertainty before expensive drilling decisions are made. This slide uses humor to introduce a serious message: the biggest Earth problems are rarely solved by one discipline alone. If geology, geophysics, and physics work together, they can help address earthquakes and faults, volcanic eruptions, climate change and carbon storage, and petroleum exploration. Petroleum engineering today is increasingly interdisciplinary, so this slide is a reminder that collaboration is not optional, it is essential. Now we begin with the most important geophysical method in petroleum exploration: seismic surveying. Seismic surveys have been used since the early 1920s and remain the dominant subsurface imaging method in the oil and gas industry. A seismic source, such as an air gun offshore or a vibrating truck on land, generates waves that travel into the Earth. These waves are reflected and refracted by subsurface layers, and the recorded signals are used to create images of the underground structure. The next method is electromagnetic, or EM, surveying. EM methods detect the electrical properties of the subsurface by inducing electromagnetic energy and measuring how Earth materials respond. Because different rocks and fluids have different electrical properties, EM methods can help distinguish between formations, fluids, and conductive zones. In simple terms, seismic tells us a lot about structure, while EM can add information related to resistivity and fluid content. This slide introduces magnetic surveying. Magnetic methods rely on the magnetic properties of rocks, which can differ depending on mineral content and geological history. One major advantage of magnetic surveying is that it can be conducted from aircraft, satellites, land, or ships, making it relatively inexpensive for covering large or difficult-to-access areas. Magnetic data are especially useful for regional mapping, basement interpretation, and structural trends. Here we see gravimetry, one of the earliest geophysical methods used in hydrocarbon exploration. Gravity surveys measure small variations in the Earth's gravitational field caused by density differences in subsurface rocks. Since different rock types have different densities, gravity anomalies can reveal large-scale geological features, basin geometry, or buried structures. Gravity data are not as detailed as seismic images, but they are very useful at the regional screening stage.